Right, look at this, please. Everyone look at this. This is basically, I'm going to look at question number 11, and then I'm going to tell you about the next couple of days' worth, and that's using the third principle, and I'll show you that right now. Hopefully all of you have sussed this sort of thing out. It's on the board. Okay? You take whatever you've got. If there's a surd, if there is a surd, that's that square root thing. That one's a fourth root. If you've got one of those, you turn it into an index. First job, you turn it into an index. So this surd thing here,
So it's an index of the power?
correct. You turn it into an index. And then you look at it and say, in this case, the quarter can come down the front because it's a power. The power goes down the front thing. That's important. Then what you've got left, you say, OK, I've got two things divided. So the two things divided becomes subtraction and so on and so on and so on. It's very systematic. Now,
How did you turn that more into a quarter? You just do it. It's just a
because that is equivalent to that. They are the same thing, one and the same thing.
So
The fourth root,
5, that'd be 1/5.
correct. The square root is a half, etc., etc. Now, sometimes, and you don't get them anymore because everybody's got calculators, these questions go back ages, but if you're told simplify log 36 over log 6, you know, sort of half of the non-thinking half-wits out there would go, oh, 6, you know, like, let's just cancel out the logs, and then that's equal to 6. You know, shoot yourself now, basically. That would be better. Yeah, so, but we have to remember, we are talking about log of a number. You've got to think of it as a power, because that's what it is. Log of a number is actually an index. It's not a number as such. So what's another way of writing 36? 6 squared, maybe. So this is that. And what's 2 log 6? Very good. 2 log 6. And if we've got log 6 and log 6, these are just numbers, the same number. There's where our 2 comes from. The log 6 and log 6 are the same thing, and they can just cancel out. So that's where your 2 comes from. So basically, for all of those questions in number 11, you're expected to look at those and convert them into a base number which is sort of common. And if you have a look at the harder ones like F, G, and H there, you've got log 3 and log 10 and log 1 over 144. These numbers, you know, 144, oh, what's that? 12 squared, you know. Straight away you could probably change that, and 12 is 3 times 4 and so on, yeah.
Could we not do it on the calculator?
Yeah, but that's why these questions are not in tests anymore, because you just get your calculator out and go log 36. But I was asked that question in 1979 or whenever it was, and we didn't have calculators. We had those logbook things, and you can't just easily multiply or divide two numbers. You actually were expected to say, hold on, 36 is 6 squared, therefore the 2 will come down the front, the logs will cancel out, it'll be 2. You're meant to do that. But now, of course, there's no need. So that's why number 11 is sort of old-fashioned, but it'd be nice to be able to do that without a calculator. Now, so what we're going to do, let's just do one more of these, for instance. Part C, log, in fact, I won't get you to do these, but try this one. Gilchrist, you can help me out with this, because you'll be good at it. It's been a while since I've said Gilchrist. Log 125 over log 25. What do you think is common to those guys? Okay, what's even more straightforward than 25? What's? Because 25, I mean, sorry? 5 is better. So log 125 is, okay, forget about the log part. 125 is 5 to the power of what? 5 cubed. So you're meant to look at that back in the day, you would look at that and go, oh yeah, I'm so used to not having a calculator that 125 is 5 times 5 times 5. So it's 5 cubed. And what's log 25? 5 squared. 25 is 5 squared. And 3 log 5 over 2 log 5. The log 5s are going to cancel. And we're going to be left with that. That is what we would have done back in the day. Now, watch this, please. We still have plenty of time. So just listen to this. Sorry? Yes. We must stop watching the this number here because it's wrong. Now, this is what I also want you to do in the next 2 days. If we've got, and it's very, very easy, if we've got 2 to the power of something equals, let's make it 32. 2 to the power of what equals 32? What is the answer? 2 to the power of what equals 32? Just do it in your head. 2's a 4, 2's a 8, 16. Okay, it's 5, okay? 2 to the power of 5 is 32. But what if the question was, work out x to 4dp, 2 to the power of x equals 30. Okay, now that would take a lot of guess and check on your calculator to get it to 4dp, because you'd go, well, 2 to the 5 is 32, 2 to the 4 is 16, it's going to be 2.9 something or up there. So this is what we do. We say, hold on, we can use, if we threw logs at this question, we could turn it into, we could use the third law. So if I write log there, I take the log of the left-hand side and the log of the right-hand side. What can I now do to the left-hand side? Correct. I can move the x down the front. And now I've got x times something equals something. What do I do with the log 2? I could minus it, but that would be completely wrong. No. I've got x times something equals log 1. And divide both sides by log 2. And so x is log 30 divided by log 2. And this I do on my calculator. And that is the original answer. Yes, it is. So this, solving equations, thank you. This is how we solve index equations. All we do is we do logs of both sides, and then we use that third property to get x by itself. Okay, really straightforward. And these are the ones they give you. And I think that's easier than all that manipulation stuff from that other exercise. Okay? I'll see you 2 days' work, fellas. So try to keep up. That'll be nice.